Hello to everybody. Let's continue our discussion on anong topic natin as equilibrium of rigid bodies. I think we have already discussed some illustrative problems in our previous videos, and perhaps this would be the last video for this chapter this chapter or topic. So let's solve this one. Cylinder is supported by a bar as shown in the figure. This figure 4, but this is the figure. The weight of the cylinder is 100 pounds and the weight of the bar is 20 pounds. All surfaces are smooth. Determine the reactions that supports A and B of the bar. So this was taken from the book of Riley. Okay. So these are the answers. So we are going to solve for the reactions at supports A. This is point A and B. So A here, anong support ito? So this is a hinge or pin support, and at B is a smooth surface yun. And we have a cylinder here in contact with the bar. So cylinder yan. So this is the front view or side view. Cylinder, mahaba yan pag ganun. Okay. Mahaba ito, perpendicular dito sa papel. Okay, so given yung weight ng bar and then weight ng cylinder. So again, yung weight natin would always act at ang line of action ng weight is at the center or the centroid or center of gravity ng isang body or object. Okay. So how do we solve this particular problem? So we are going to solve for the reactions at supports A and B. Alright, so ang approach na dito, first of course is we need to know yung force dito sa may contact between the cylinder and the bar here. So merong reaction ito. So smooth surface yan. So sabi sa problem, all contact surfaces are smooth. Smooth surface din ito. So basically, merong a portion of the weight of the cylinder is being carried by yung bar. So we need that para ma-solve natin yung reactions dito. Okay? So first, we analyze yung cylinder muna and solve for the reaction at this contact surface. Okay? And then, i-transfer natin yung reaction niya dito, okay, sa may bar, and then we will now be able to solve for the reactions at the supports A and B. So let's draw the free body diagram para mas maintindihan natin. So i-separate natin yung cylinder. Okay. Maybe I'll just draw it here. Alright. So, ano yung mga forces acting dun sa may cylinder? Of course, meron tayo. So, this would be the center of the cylinder. So, nandyan yung line of action ng weight natin. So, given yung weight ng cylinder na 100 pounds. At meron din, of course, ano pa ba yung ibang forces? May smooth surface to, contact surface ito. So mayroong reaction itong surface relative to yung sa cylinder. So perpendicular dun sa surface. Okay, nasa yun, yung line of action niya ay dumadaan dun sa may center. So this is R. So reaction sa may smooth surface. And of course, meron din tayong reaction dito. May reaction tayo dito. So may smooth surface na yan. So that is draw lang natin yung Cartesian. Kasi may angle tayo. So meron tayong also reaction here. Reaction sa may smooth surface. So let's say this is R1 and this is R2 na lang. Okay? So yan. So ang gawin natin, we need to solve for R1. Okay. And then later on, transfer it dito sa may bar. and then solve now for the reaction dun sa may supports A and B. So first, yun muna ang gawin natin. Don't forget also yung angle. So inclined yung ating bar at 30 degrees. So dito siya, ano? Yung angle natin. So 30 degrees siya. Ibig sabihin, this is also, pag nag-transfer tayo ng angle, this is also 30 degrees, or this is 60 degrees. No? That's 30 degrees. Yeah. So any angle naman dyan ay pwede natin gamitin. So solve muna natin. Ang concern lang natin, of course, is yung R1. So how do you solve for R1? So parang equilibrium of particles muna ito. Equilibrium of particles. Ayan. So sa equilibrium of particles, since we consider this to be a particle, walang moment, ano? For a particle to be in equilibrium, may dalawang conditions, no? So the summation of forces along the horizontal axis should be equal to 0, and the summation of forces along the vertical direction should also be equal to 0. Now to solve for R1, ano ang gawin natin? So we can summate forces along the vertical direction, which is the y-axis. It should be equal to 0. Now, so upward forces positive. So R1, yung kanyang ano, this is R1x. Sorry, that's R1y, this is R1x. Medyo bangag pa. Alright. So, R1y. So, ano yung R1y? That is R1. Adjacent side siya. And it is upwards. So, by the way, yung direction ng R1, so that, discuss ko na muna ito before nandun sa may, ano, sa may support reactions. Yung nandun sa may table. So, yung smooth surface, so perpendicular siya dyan. Okay, so yun yung direction ng R1 natin. So, upwards yung direction ng R1, so that is positive. R1y should say. So, R1y is R1 cosine of 30 degrees. Okay, and then downwards naman yung no, weight natin. So, that is minus 100. Meron pa bang mga vertical forces? Wala na. So, equate that to 0. So, R1 is equal to 115.47 pounds. So, this is R1. Okay. Ngayon, since you do not need to solve for R2 kasi hindi naman natin siya kailangan sa pag-solve ng reaction sa may supports A and B. So, R1 now, i-transfer natin to dito sa may bar. So let's again draw a free body diagram. Let's just use this one na lang, itong bar na ito. So since sasagot natin yung R1, so if you try to imagine yung effect ng cylinder sa may bar, so it would now try to push it pag ano, because of the weight of the cylinder, ano. So ganun yung direct ito kasi itong R1, yung direction niya pag ganun because that's the reaction, no? Yan yung reaction niya. Okay, for this cylinder to be in equilibrium, ganun dapat yung reaction niya. But the action of the cylinder relative to the bar, ganun siya. Okay, so this is R1, which is equal to 115.47 pounds. Okay? And then, may reaction tayo dito sa may, let's just use this one na free body diagram natin. A, sa may hinge A or pin A, so this is, let's say, RAY. And this is RAX. And then, smooth surface sa may point B. So, kapag smooth surface, perpendicular yung reaction that relative to the surface. So this is, let's say, RB, the reaction at B. And then considering the bar, so since itong cylinder, palitan na natin ng R1, so you do not, you can neglect yung kwan since we have solved for R1 naman na. So again, we should focus on the bar and solve now for the reactions. Okay, so again, so since this is we need to to meet the three conditions again of equilibrium, that is summation of moments should be equal to 0, and then summation of forces should be equal, summation of forces along x-axis should be equal to 0, and summation of forces along y-axis should be equal to 0. Okay, so ano ang unahin natin? Maybe we can solve for anong gagawin natin? Summate moments where two or more unknown forces are located. So I think na-mention ko yun sa mga previous videos para ma-eliminate yung moment ng dalawang forces na yun, or two or more forces. So summate moments where two or more forces are located, and that is at point A, sa may hinge. So summation of moments, at A is equal to 0. Ano yung mga may moments sa A? We have R1 and then RB. So with this, we can solve for RB. Ano? So RB creates a counterclockwise moment about A. So again, ang ating sign convention is clockwise positive. Okay? So RB times its moment arm about A. Ano yung moment arm ng RB about A? Ano? Kaya ang moment arm niya. Ano yung moment arm? That is, itong distance na to. Yung perpendicular distance. Ito, yung moment arm ng RB about point A is this distance, horizontal distance na. So yan yung perpendicular distance between these two points. So that is, this is 30 plus 20 is 50 adjacent side. Ito yung ating hypotenuse. So cosine, ano? So RB times 50 inches cosine of 30 degrees. Again, RB creates a counterclockwise moment about H, so the moment should be negative. What else? Ano pa yung mga may moments sa A? Ang may moments sa A ay yung R1. Okay, and R1 creates a clockwise moment about A, so that is positive. So R1 is 115.47 times its moment arm about A. So perpendicular distance, ito. Remember, this is perpendicular to this surface. So, ito yung moment arm niya na 20 inches. Okay, ano pa yung mga may moments sa A? Oh, we forgot to include yung weight. Meron palang weight yung bar, 20 pounds. So, nasaan ulit yung yung line of action ng weight? Nasa may center of gravity, centroid, or center of mass ng body or object. So, 50, it's somewhere here. Okay. And weight always acts downwards. Yung weight natin. This is 20, it's 20 pounds. Okay. So may moment yung weight about A. Okay. So this distance is, itong distance na to, since nasa center siya, this is 25 inches. Okay? 25 inches. So the weight now creates a clockwise moment about A. So plus 20 times its moment arm about A. So again, downwards yan. Ano yung kanyang perpendicular distance? Itong distance na to. Moment arm niya. Itong distance na yan. Ang moment arm ng weight about A. And that is cosine again. So 25 cosine of this is 30 degrees. So 25 cosine of 30 degrees. Okay? Ano ba? Wala na. So equate this one to 0. And we can solve the reaction at smooth surface B using this equation. So ano yung RB natin? RB is 2742. Ano ba ito? Sorry. That is 63.33. Ayun pala yung sagot. So anyway, yun ang lalabas sa ating calculator naman. So 63.333 So that is the reaction at smooth surface B. And now we can now use the other conditions of equilibrium to solve for the reactions at A. No? So we can now summate the forces. So summation of forces along, let's start with the x-axis equals 0. So forces to the right is positive. So ano yung mga horizontal forces? So RAX, we have assumed it to be directed to the right. So RAX. We have the horizontal component of R1. Ano? So meron siyang component dito. So R1X, R1Y. Okay, so horizontal component niya ito. And that is equivalent to, directed to the left siya. So minus R1 sine of 30. R1 is, solve na pa natin yung R1. So 115.47 pounds. Sine of 30 degrees. Okay, so sine of 30 degrees. Meron pa bang horizontal forces? Wala na. So equate this one to 0. So RAX is equal to 57.735. 57.735. So this is RAX. And then lastly, summation of forces along the y-axis, upward forces positive. Oh no. Ayan, para makita natin sa video. Or I can just, dyan na lang. Ito na lang. Summation of forces along y-axis is equal to 0. Ano yung mga vertical forces? Medyo marami. So we have RAY, which is assumed to be directed upwards. And then the weight, so minus, downwards yung weight natin, 20 pounds. Yung R1Y na downwards din. So minus R1Y. R1Y, that is 115.47. Okay. Cosine ba yun? Tama. Cosine of 30 degrees. Ano pa ba? Yung RB. Don't forget yung RB na upwards. Plus RB, which is 63.333. Other vertical forces, I think we have already included all vertical forces. So we equate this one to 0. Now we have RAY left in the unknown in the equation. So RAY is equal to 36.667 pounds. Okay, so that's it. That's how we solve this problem. Okay, so let's proceed to another example. Let's solve this one. So meron tayong pulleys. A rope and pulley system is used to support a body weight. Ito yung weight natin, as shown in the figure. Each pulley is free to rotate. One rope is continuous over pulleys A and B. Ito, continuous ito. Yan, isang rope lang yan. The other continuous over pulley C. Ito naman yon, continuous siya. And then determine the tension T in the rope over pulleys A and B. Ito, required to hold the weight in equilibrium if the mass of the body is W is 175 kilograms. Okay. So yung weight natin is 175 kilograms. Convert na lang natin sa newtons ito. So you multiply this one by gravity. So yung weight natin is equal to Yan to. 1716.75 Newton. So yan yung weight ng block na ito. So what are we going to do? Sa pulley system, kapag nasa equilibrium, of course, pag isang rope yan, ibig sabihin isang tension yan. Ano? Isang cable or rope ay isa rin yung kanyang tension. Isa rin yung tension nito. Okay. Hindi magkaiba yung mga tensions ng bawat segment. But basta iisa ito, continuous yan, iisa yung tension dyan. So we're going to analyze it by pulley na lang. Pulley by pulley. So let's start at pulley C here. So pulley C. At pulley C, let's draw the free body diagram. Kasi nandun yung known na weight eh. Doon tayo mag-start kasi alam natin yun. We can solve for the tension dito. And then if we are now able to solve for the tension at this rope, so may rope C, alam na natin ito. So we can cut that. And then now solve for T using equilibrium conditions. So at pulley C, i-cut natin yan. Pag kinat natin, so cable, again, palaging away. Kasi cables cannot resist compressive forces, compression forces. So, magkadugtong yan. So, if this is TC, that is also TC, and we also have the weight here na 1716.75 Newton. So, ito yung free body diagram natin at pulley C. Okay. So, again, if nasolve na natin, ito yung TC, TC yan. So, pag nasolve na natin yan, we can now solve for the tension using equilibrium conditions. Okay? So, summation of, since all forces naman ay vertical, forces along the y-axis is equal to 0. Upward forces are positive. So, we have TC, dalawang TC. So, we have 2TC. So, TC plus TC, 2TC. Minus yung weight natin na 1716.75, equate that to 0. So we can now solve for the tension at cable C, which is equal to 858.375 newtons. So that is TC. But we are not solving for, kailangan natin ito para ma-solve natin yung tension sa my cable AB. Okay? So if TC is equal to this, now let's go to pulley B naman. Drawing ulit natin yung free body diagram sa may pulley B. So at B, may cable ulit tayo. Okay. So let's say this is T. Kasi isa lang naman yan, di ba? T yan. This is T, T, and this is TC, which is equal to 858.375 newtons. So, applying the conditions of equilibrium, all forces naman ay vertical. The summation of forces along the vertical direction y equals 0, upward forces positive. So we have 2t minus tc, which is 858.375. That is equivalent to 0. Okay, so t here is equal to 429.188 newtons. So that is t. Nandun yung sagot natin sa may module. Okay, so that's how we solve this problem. Okay, next, perhaps the last problem. Dami na natin sinolve, no? Okay, next problem. Determine the support reactions of the beam loaded as shown. So we have this beam. We call this a cantilever beam, ano? So cantilever or overhanging beam. Meron siyang overhang dyan. Ito yung support niya na fixed. So this is a fixed support. fixed support. So kapag fixed support, ilan yung reactions? Tatlo. So isang vertical component, horizontal component, and then we also have yung moment, no? So tatlo yung reactions niya dito. So suot na lang natin dito. So we have label na natin para let's say this is 0.0 na lang, 0.0. So R, O, Y, and then we also have R, O. And you can assume any direction naman yan. But obviously, since all forces are vertically downwards, ma-imagine nyo naman sa Newton's third law, kapag itong forces natin ay downwards from Newton's third law, the reaction should be upwards and the direction should be upwards, ito yung reaction natin. Okay. And then don't forget yung moment. So you can assume any direction ng moment. Ano kayong direction ng moment? It's difficult to identify, no? So maybe clockwise yung moment natin, MO. So may reaction na moment yung kapag fixed support, because fixed support can resist rotation or moments, no? Ayan, so apply the conditions of equilibrium. We can summate forces along the horizontal direction, equate that to 0, forces to the right positive. Lahat ng horizontal forces. Ano yung mga horizontal forces? RO, wala. Yung reaction natin, ROX. So, walang horizontal forces acting on the beam. So, obviously, ROX is equal to 0. No, wala tayong horizontal component. Next, summation of forces vertical is equal to 0, upward forces positive. So, ano yung mga vertical forces natin? Yung ROY, directed upwards, assumed, you know? And then, we have these forces. So, 160 kN force. And, meron tayo, i-resolve dapat natin to into component, the resultant force, F, let's say F na lang. Rectangular loading, so ano yung component, so ano yung resultant ng rectangular loading, yung area lang niya. So area ng loading natin. So we have 15, ito na natin isolve yung ano, this is 15, base times height lang, 15 kilonewtons per meter times yung base natin na 6 meters. So that is equivalent to 90. So cancel yung meters dyan. So yeah, that's 90 kilonewtons. Okay, so okay na. ROY minus 160 kilonewtons minus ito 15 times 6, which is 90. Meron pa ba? Wala na. So equate natin yan sa 0. So ROY is equal to 250 160 plus 90, so that is 250 kilonewtons. Positive yung result, so ibig sabihin tama yung assumption natin na ROY is directed upwards. Okay, so that's ROY. Next, we solve for the moment here, yung reaction na moment dyan. Okay, what we're going to do is to solve for, we summate moments at O. No? We summate moments at O, since nandun yung support natin. Equals 0. So, clockwise moment, positive. So, summation of moments at O. So, ano yung mga may moments sa O? So lahat ng forces except itong reactions natin. So walang moment yung ROY about O, no? Kasi nandun yung mismo yung point natin. Ito, 400 kilonewton meter. Okay, so clockwise siya sa positive. Ano pa ba? Yung moment ng itong force natin, yung resultant ng rectangular load, it creates a counterclockwise moment about O. So yung rotation niya is counterclockwise. So that is minus 90 times its moment arm about O. So yung force natin dito sa gitna, so that's 3 meters, 3 yan up to this point. 3 plus 4 plus 4. Okay. So that is equal to, hindi yun na nilagay natin dyan. 3, so this is 3 meters. Okay, plus 4 plus 4. Yeah, alright. Next, that's the moment arm of F. And then, lastly, meron pa mamaya, itong 160 Newton force, kilonewton force, may moment siya about O, which is counterclockwise, so subtractive siya. So, minus 160 times moment arm niya is 4 meters. And don't forget yung reaction natin dito sa may point O. MO, in-assume natin na clockwise. So, plus MO, equate natin yan sa 0. So, we have MO unknown in the equation. MO is equal to 1, 2, 3. Ano ba? 1, 2, 3, 0. Kilonewton meter. So, yan yung reactions natin. So, ROX, ROY, and MO. Yan yung reactions natin sa may support, fixed support at point O. Okay? So, that's it. That is chapter 5 or ano yung chapter 5? Chapter 5 ba? Yeah, I think it's chapter 5. Equilibrium of rigid bodies. Next chapter na tayo.